everyone. It's a chilly winter evening here in India, and the students have had a very long day with online classes, assignments, and whatnot. Yet, the fact that you all have showed up here shows your keen interest in learning and enhancing your knowledge. So, we, the core committee of Sophisticated and Perpetual Coders Association, SPCA, welcome you all for yet another event organized on this very interesting and wide topic, data engineering. Just a second. Go back to what I said a few seconds ago. It's a chilly winter evening here in India. Why did I emphasize?
Is someone supposed to speak?
Yeah, I guess she lost her network connection. Vivian, sir, could you please continue?
Hello, am I audible?
Yeah, go ahead, Tina.
Okay, I'm so sorry. All right, so the guest for today, who is the resource person, is Mr. Naveen Chaganti, who is a data engineer in Adobe, New York. So, good morning to you, sir, all the way from India. We at St. John College of Engineering and Management have this tradition to commence every event only after the wise words delivered by our respected principal, sir, Dr. G.V. Mulgund, and by our respected HOD, sir, Dr. Rahul Kokle. So I now request our respected principal, sir, to address us all.
Thank you, Dinah. Good evening to all fellow members from St. John family, as well as very good morning to the resource person. And at the outset, I would like to congratulate Department of Computer Engineering for having this particular session on the data science. To me, data science is nothing but amalgamations of the science, the statistics, the mathematics, the algorithms, IT tools, and is a dynamic in nature as compared to any other physical science of whatever we have studied. We used to study in MATLAB, all the analysis can be done, whereas it is a combination of statistics and use of the IT tools, which can be applied to all fields of the engineering. Also predict that whatever the present tools available with the data science may not be valid over the 10 years of the time. But I am also aware of the fact that this is the most burning and latest field that is fetching a job and which is making every student to think laterally and apply their logic. And will going to stay for another years to come. I know that there are so many openings. That's why AICT as well as so many other universities in India as well as abroad, they are taken out and carved it as a separate course only, program only in most of the universities. This also includes AI, machine learning, and so on and so forth. I hope this particular seminar will going to give us the wide depth of this particular engineering and what will be the row ahead for the present students, so that they themselves are going to get equipped and they're going to get themselves prepared for the coming tomorrows. And I wish at this particular occasion, belated Deepavali greetings as well as New Year greetings to our fellow speaker. I presume Mr. Naveen is our alumnus, and I think I met him on our alumni meet. I once again thank and congratulate the department for taking this particular initiative and let the outcome of this be fruitful to one and all. Over to you, Diana. Thank you.
Thank you, Principal Sir. Yes, indeed, we too have a lot of expectations from this particular webinar. So I now call upon our HOD Sir, HOD of Computer Department, Dr. Rahul Kokle, to speak a few words.
Well, good evening, respected principal, sir. Resource person of today's knowledge sharing session on data engineering, Mr. Naveen, faculty coordinators for SPCA, Vivian Lobo and Anjali, as well as all the students, office bearers of SPCA. So, a very good evening to all of you. Now it's a great experience to have a very knowledgeable and resourceful person as a resource person for today's knowledge sharing session, Mr. Naveen, and he is going to impart his knowledge on this particular emerging field to all of us. So, today, data engineering is one of the most demanding area in today's scenario. As we know that today data is increasing with very high speed, with the volume of data is also very large, and there is a diversified variety in the data. So data, simply having data is not enough. So unless and until we interpret the data, we extract the information coming from data, information from the data has no meaning. So knowledge engineering is basically, it deals with extraction of the meaningful information from the data, which can be used for the decision making and other important business intelligence purposes. So now today, all of you, all the participants will enjoy the session of Mr. Naveen. He is going to impart his knowledge on this particular domain and what data engineering is, what are the future prospects and what kind of projects can be done in this particular domain, data engineering, and what are the opportunities and all. So now let us enjoy, let us listen to him, and let us try to acquire as much as you can acquire, as much as you can acquire the knowledge from him. So over to that.
Thank you very much, HOD Sir.
Okay.
Dear participants, please keep a note of all your questions or doubts which you all want to convey to the resource person. And after the end of the session, we shall have a Q&A round. So there you all can post your queries in the chat section. Thank you. So now we have we have been notified by a resource person that this shall be a one of a kind type of webinar, and it shall be very interesting and lots of things are going to come up. So I won't be dragging this any more further, and I request Mr. Naveen Chaganti to take over.
Thank you so much. Thank you, Principal Sir and HOD Sir. That was a very warm welcome. I hope you guys can hear me well. I'm going to start presenting. Screen. I just hope I don't share anything inappropriate. Okay, cool. I hope you guys can see my screen now. Just give me a minute. So sharing. Okay, awesome. I hope you guys can see my screen now. If you could confirm that would be great on WhatsApp.
Yes, we can.
Perfect. Let me see. Okay, I'm good. So thank you again for having me here. So again, Shweta had reached out to me, and then I was coordinating with Vivian regarding a session on data engineering. And what I've been thinking about this session for a while, and I went online. I was searching for resources about data engineering, and there's a ton of information about that. But what's happening is that it's pretty confusing because there's so much information, and every other guy today is trying to be a YouTuber and just try to upload whatever they want to express. So there's a lot of confusion around what this field is, and it's important and significant. So I'm just going to walk you guys down through what the field is about, and also I'm going to have a guest speaker or a friend of mine. He basically works as a vice president for Mitsubishi Bank in New York, and I'm going to have a more podcast kind of a Q&A session with him so that you can get a better experience from him. And I'm going to introduce him later in the session once I'm done. So let's get started. So basically, my goal today is help you to solve all your myths around data engineering. Again, I'm going to keep this session very informal. If you guys have been to my previous sessions or previous one session, you know that. So feel free to ask questions later in the session. But what I'm going to do is basically help you guys to understand what kind of roles you guys do, what kind of a job does a data engineer do, what kind of impact they have, and what kind of value they create at a firm. So what I think I do as a data engineer is I join data. So currently I work as a data engineer for Adobe, and what happens is that I pretty much drink a lot of coffee from Monday to Thursday and a lot of beers on Friday. But the end goal of my job eventually is to join good data and basically try to get as much as value out of it into products and dashboards and reportings and etc. So that's one of the core, I would say, or the most final outcomes you need to perform as a data engineer to finally get some value out of it. So jokes aside, I'm basically going to be talking about the goals of a data engineer. What does he do? What kind of skill sets do you need, or a data engineer should have? How to design data pipelines? Actually, what are data pipelines and its significance? How to design a data pipeline is a whole different session of its own. So I won't get deep into that. The tools you need as a data engineer, to survive in this stream, the kind of interactions you do with people, what kind of people do you talk with in the firm, and the impact you create being a data engineer at a firm. And again, there are a few misconceptions about data engineering and data science. I would briefly go on that just to clarify how data engineering is different than data scientists and BI engineers. Again, the reason I wanted to put this out here is because data engineer role has, I would say, specialized on its own in past 5 to 6 years. Earlier, there was no such role. Everything was one. But now all these three, data engineering, data scientists, and BI engineers, all I would say individually specialized roles. So I'm going to briefly talk about how data engineering is different to them. So going ahead. So what are the skills a data engineer needs, right? So I've listed the 4 things here. This is data modeling, automation, ETL development, product understanding. The reason I have picked these 4 is just not because I think it is. It's just what I've experienced when I've interviewed with a lot of companies. And I've interviewed with pretty much almost all, I would say, the top companies in the US. And what happens is that, for example, my previous interview experience with Facebook, I understood they have a separate round for data modeling. They have a round of ETL and scalability, of automation, of working or having a chat with a product manager or management to understand how can I communicate, how can I interpret technical ideas into business ideas. So I've basically broken my down. I basically worked on my session in a way that I'll explain each of these, and that can give you a better clarity of the skills a data engineer needs to be a good data engineer or just to survive in this industry in general. Cool. So first thing, data modeling. So data modeling is one of the most important concepts you actually learn it in your undergrad. But I've heard and also felt that this is actually really boring to learn, especially in the theoretical aspect of it. But once you start working as a data engineer, right, you start understanding the importance of the skill set. Most of the good companies, one of the first interview rounds, the first questions they have is on data modeling. For example, when I was interviewing with Netflix, the first question I was asked was basically a data model on SCD SCD type 2 on Hive. And in Facebook, again, there is a use case scenario where the engineer wants you to basically draw a data model on a particular use case. And that's the kind of rounds they have. And so I feel this is a very crucial aspect, especially because this is one of the most fundamentals of data engineering. And why is that? So usually what happens in data modeling is you're just taking a very messy data model or a messy data, and you're converting your everything from there to a better pattern, into a more, I would say, more readable, more better queryable, and to be more simplistic in terms, you're trying to basically make a star schema or a snowflake schema. And And the reason you were trying to do that is because, as you can see in the left-hand side of the slide, the relationships are really messy. So even to get like basic information out of this, out of the messy model, you have to do multiple joins. And you might think, okay, what's the big difference? Like, it's just multiple joins. We can just go ahead and we can just build it. So, but the issue happens is when your data starts scaling up, your data grows really fast. All these joins become really expensive, and these processes start becoming very slow. So it's very important to design your systems in a way that you can push in data into you have the skill to convert a messy model into a proper data model, which can be queried easier, read easier, understood easily, and maintained easily. So going to the next slide, ETL development. ETL development, one of the issues with ETL development, not issues, the thing with ETL development is that you guys don't learn this in undergrad. You guys don't learn this in school regarding the end-to-end ETL development or ETL pipeline. And that's one of the blockers you have on your resume to get selected for a data engineering role, because most of the recruiters look for that. And as a new grad, it's difficult to have it if you're not really researched about this field or if you don't know much about this field. So a lot of new grads have a very big, I would say, issue cracking a data engineering job. And that's basically why I'm going to talk about this a bit and explain what this actually is. So ETL development is basically just taking your raw data or data from multiple sources, pushing that into a data warehouse. And this data can be anything. It can be a MySQL server, it can be a S3 bucket, it can be, any operational system logs, anything. So you're basically taking this data, you're dumping into a data warehouse. And again, data warehouse, the term data warehouse has significantly changed in last 10 years. So I'll just keep it simple. This can be anything in like a cloud, a bucket, or just a warehouse or a Hadoop warehouse or something like AWS Athena, where you're pushing data into a more, I would say, data warehouse-ish platform. And once you have your data there, you take this raw data to do your transformations, and you eventually push your data into an analytical data layer. And what I mean by that is, sorry about that. Oops. So what I mean by that is that you basically are taking your raw data and pushing it to analytical data layer. It basically, an analytical data layer can be anything. It can be a MySQL, or it can be AWS Redshift, or it can be Oracle database. But the whole purpose of pushing that data from a data warehouse to analytical data, raw data you get a really clean CSV file. It's not a really nice structured data. It's usually unstructured data or messy data or bad data, which you need to filter out and you have to push it in. And the reason you have to push this into a more, I would say, reportable or into a more cleaner format is because you can eventually start querying on it. Like analysts can start querying on it, data scientists can start working on this data and create models on it. And eventually you power your Tableau dashboards, or you basically are reporting dashboards through that data. So this is usually a typical end-to-end pipeline, which most of the data engineers' job is to basically own, build, and maintain it. And this is something I personally do at Adobe. I almost get 30 to 60 terabytes of data every day, of clickstream, pretty much everyone from throughout the world. And I have to basically build this data pipeline and make sure all the data transformations are happening properly, all the reports are getting refreshed daily. And it's a very crucial aspect of this job role. So next is product understanding. What do I mean by this? This basically, what I'm trying to illustrate in this is that data engineers, yes, you clean data, you do modeling and stuff, but the purpose of doing that is basically to understand how your product is going to be. So it is how will the data look, how will the dashboards look, right? So for all that, you need good clean data. For good dashboards, for good reporting, you need good data. If your data scientist wants to do good machine learning or neural networks and things like that, you need to create you need to have good data first for that to happen. And that's where the product understanding comes. Data engineer basically works with a lot of management and project managers and upper management to understand, what can be done with the data and what kind of exploratory analysis can be done. For example, there can be a use case or a story where you work with your product. You're trying to understand how a digital advertising can be done well, or you're trying to understand how to reach your customers better, or understand how sales reporting is being done. So for all these things, the first person they try to contact is the data engineer and basically help them build this end-to-end pipeline. So that they can have that data to eventually do this dashboards or machine learning, which is the end product of all the data cleaning. So next comes also one thing I wanted to mention here is that again, it's a skill you need to have in product understanding, or it's a skill in data engineer that need to have, is that you should be able to communicate your technical requirements into business requirements. So, which is a very essential skill, and that's actually a very big game changer, which most of the big companies look for. And it's a skill you gain with experience. The more you start working on, as a data engineer, you start understanding what kind of data exists and what kind of value you can create from it. So, this is something you learn while you do the job. Going to automation. This is a boring but a very crucial aspect of data engineering. And what I mean by automation is that, it basically is the system which keeps it basically is the process which keeps your systems running, right? You need your data to be processed in a certain time manner. Okay, like for example, if a bank is processing all the credit card transactions, and if they miss a deadline of their daily processing of data, what can happen is that the bank might not have processed all the credit card swipes or something, and this can cost them millions of dollars of losses. So in data engineering, timing is very important. To make sure that your data doesn't go stale and your data doesn't lose value. Okay, and so it's very important to meet these deadlines in a certain time, and also factor in dependencies. You just not want to finish it in time, but you also have to understand that processing data is just not one CSV file. You run a particular Python job or something on it and it finishes. There's a lot of, I would say, data dependencies which are happening. Your data has to come from multiple sources in different formats, and you have to factor all those in and basically create a workflow in a way that if A happens, then B happens, or else you need to wait for C to happen. So, and you have to factor in all these workflows, and you have to build your tool according to it, or your workflow according to it. And then failures. Failures is very common in data engineering, just because the volatility of the whole world in terms of data right today. Your API changes pretty much every year. New columns get added, new data fields get added, data fields get removed, and sometimes even so. All these factors keep on happening in data engineering, and there are constant failures. So it is very essential for the engineer to learn from these failure experiences and keep building and keep learning those experiences and trying to make this process more self-healing and more reliable, and that increases your value as a data engineer a lot. So again, I've been talking about modeling and everything, and so why do you think developing data pipelines is so essential, or why do data engineers need to develop the data pipeline, right? So the first and foremost thing for this is that you need to have data access. And what do I mean by data access? So the thing is that every time you need a data scientist or a data analyst or a product cannot go and keep searching for data and learn these whole complicated Hadoop big data tools to just do a small report. He basically contacts a data engineer to do that and basically get him to a format which is more easily readable and more understandable. And if a data scientist is working on cleaning the data 80%, he's just working 20% on creating models, and that model won't be good. So it is basically data engineers' responsibility to basically work with the data scientist or an analyst to get the data into a better format that they can just start using it instead of working on processing it. Next comes producing analytical layers for dashboard. Most of the data dashboards which I mentioned are usually the products which a lot of companies sell. These are not powered with raw data. most of these analytical dashboards are more lighter, like they are in a more readable format. So for that, they are in a more cleaner format, and they usually read from AWS Azure, MySQL, or Snowflake. These are more SQL-based servers. And what you do is basically you run your complex SQL queries on it, and then you create reporting dashboards or analysis. So it is very essential to provide that layer as a service and understand the skill you need to get your state of raw data to eventually a faster running SQL engine, so that you can provide better dashboards. And what I mean is that this layer basically decides how complex of dashboards you can build, how complex of machine learning models you can build. Because the more faster and more cleaner this data is, the better your product will be. So again, last is cleanup data. This is extremely important. And what I mean by this is this, basically. If the data is not cleaned properly, okay, or if the data is bad, it basically creates, probably bad recommendations or bad graphs. And what does that mean? So, for example, in a digital advertising world, it can be that you're targeting wrong clients, or your bad data is generating bad sales reports, which your analyst or your management is reading, on which they will make bad decisions, and they'll spend a lot of money on wrong things. So that's what happens when you have bad data. So it's very important to learn and understand and find these issues of why the data is bad, if it is bad, and how to clean it and make sure it doesn't land in the final stages. So before I get deep into this slide, I would just talk about this. In this slide, basically, I was going to be talking about tools. But before I get deep into this slide, I would like to share a small journey of mine in big data itself and how it began. So as I mentioned, around 12 years ago, there is Google basically launched its Hadoop, or Google File System research paper, through which Hadoop came out. And around, I would say, 8 years ago, or around in 2012, that's when I started learning Hadoop. And most of the stuff back then was in Java. All the MapReduce components and everything was in Java. And that was everything. Java was the thing you needed to know if you wanted to work on big data or on data that time. And later, around in 2014, is when Spark released, Apache Spark. It's an in-memory distributed computing engine, which is built on top of Hadoop. I won't go into details of it, but when that happened, what happened was that that was built in Scala, but it also had an interface to Python, and a lot of data science was booming up during that time, and that's when Python started becoming more famous, and a lot of engineers started incorporating Python in their technical stacks. So, and that was the whole journey on why now Python and Spark is the more hotter tools, or a tools every data engineer should know. But the reason I'm trying to tell you this journey is that most of the stuff earlier was again on-prem servers. Now it's everything is on cloud. So what I'm trying to say here is that data engineering is a field which evolves almost every 2 years. And there can be a situation where in next 2 years, all these tools I'm mentioning right now may become obsolete. And you need to be ready to learn pretty much a new tech or a concept every 2 years to become a good data engineer or to survive in this field in general. But again, it's very important to understand that the fundamentals are very important. Everything I talked about till now, right? Those are the fundamentals, and those fundamentals don't change. And if you interview with any good data engineering company, the gold standard of data engineering jobs are Netflix and Facebook. So these engineers are probably the best data engineers out there and the best paid too. Okay, and if you interview their rounds, they never ask you about a tool. They never ask you about a certain programming language. They ask you whatever programming language you're comfortable at, and they ask you about the concepts. They ask you about data modeling. They ask you about how will you design data pipelines. They ask you about how will you solve issues and your problem-solving approach. So again, before I really wanted to emphasize on this before I get deep into this. And by showing you this slide, I don't mean that you guys should become experts in this. This slide just means that these are the current frameworks right now which are happening. or being used in the data engineering field. So I'll quickly go through them. The first framework is the Apache Airflow framework, which is a pipeline framework or the orchestration framework. And this was actually built by Airbnb. And imagine, right? So Airbnb, a hoteling chain, built Airflow. So that's how that's how much important data engineers are. They basically really reshaped how hoteling industry worked, right? So they basically developed. There was a open source project. It was an internal project in Airbnb which became open source, and that's how Airflow came in. It's an orchestration job to run your job, all your computing jobs, and Airflow is usually combined with Spark to do pretty much all your ETLs. Most of the people use SQL for the reporting layer. A lot of business analysts and even use SQL. Even a lot of data engineers use it for analysis of data. Python again is the most, I would say, the most common scripting language or the coding language they use. And most of the dashboards which get powered are from Tableau or D3GS. So these are, if you have these skill sets as a as a data engineer, it's pretty good. You're you have a very good chance of getting calls, or you have a very good profile in general. Okay, again, this is something what I wanted to iterate on. Right now, the most I would say liked framework is Python. No one uses Excel anymore. The hottest frameworks now actually are people going towards machine learning and deep learning and trying to use those concepts in the reporting of data engineering. But again, that's very few people. Mostly Spark is pretty famous. TensorFlow is nothing but a deep learning tool. I don't know how many guys know about it. It's not exactly a data engineering tool. And finally, Java. Java is like something people are going away from, and most of the companies right now don't, as far as I know, don't use Java as a core language for data engineering. So, what impact does a data engineer make, or what is their role? So first is creating optimized pipelines. So I've been talking about data pipelines till now, and why does it matter? Okay, so before I go, I want to show you this slide because this is something which has actually happened with me. So when I joined Adobe, I actually ran a job, a MapReduce job or a Spark job, which didn't run efficiently, and I didn't scale the clusters properly. I didn't close it. So what happened was in my initial few months, my compute cost was around $40,000, just mine, and that's around 28 lakhs. So that was the compute cost because of the inefficient code I wrote. And my boss was really angry, but he couldn't fire me because there's no one else during that time my team had which has the skills to do that. But again, I want to share another story where just a few months ago, I was working on a report, and that report was basically one of the most complex cell joins, I would say, in the industry, and which was basically trying to understand the sales report of companies, and that's what we sell as a product. And this one dashboard was costing us $1 million of compute costs every year. That's basically 7 crores. Okay, just one dashboard. That much. That's the cost of that dashboard every year for us. And because of the computing complexity of it. And what I was able to do was I was able to use an alternate machine learning approach to solve that problem instead of a brute SQL-based approach. And I could get the cost of the report from $1 million to $10,000. That basically is from 7 crores to 7 lakhs. And that's exactly the figures I'm talking about. And what I'm trying to emphasize here is the impact you make by creating an efficient pipeline or an inefficient pipeline. If you create an inefficient pipeline, it's going to cost people a lot of money. And if you create better pipelines, you're going to save a lot of money and you're going to make a lot of people happy, obviously. So it is very, very important to understand and learn the concepts of how to build optimized pipelines. And that's basically what all the things I've talked about in the previous slides. Better data modeling, better architecture in the ideal tools, failures, etc., etc. So that's how you can create an impact just with, I would say, creating better data pipelines. So the other aspect is influence. What kind of influence do you have? Like Mara what care, in the office, right? So you actually have a lot of influence, especially for most of the companies when you're a data engineer, because you're the person who's feeding everyone data. And what happens with that is that everyone comes to you first, like to get access of data or to talk about a product. And the better data you have, and the simpler data you have, the more complex dashboarding, so machine learning things you can do, and that basically will create, like indirectly will create a better influence in the company. Because if you're making sure that there is good data, there'll be good recommendations. With good recommendations, there'll be good sales and be revenue. So you automatically create that impact by creating, good data, and that kind of influence is automatically generated with your work. Next is designing. Again, it's very essential for good data models, because again, good data models could create good reports. You reduce the complexity, and it makes a lot of data scientists happy, because their job is now to focus more on the models, more on the machine learning concepts of it, instead of focusing on how to clean data. And that basically creates like much better design to create more complex machine learning stuff. And again, all the companies who are doing really cool machine learning or deep learning, they have very solid data engineers, or they have a very solid data, and only then you can build that kind of complexity on it. So data engineer basically helps to design like the future of the firm. So that's the other kind of designing aspect, impact you make. And maintaining, right? So it's very it's very essential for the data engineers to maintain data in a better format, in a good fresh format, or not getting stale, or basically making sure that things don't fail. Like people are not getting phone calls at like midnight that the data is not working, or they can't see the report or something. So that is also very important, because if you don't see your data, right? So in a bank, it might be like not seeing your details on your account. You won't be happy, and that will create a very bad impression. So this is very important also. Like if a data engineer doesn't maintain things, you basically are crashing the whole, I would say, the infrastructure of the company. So it's very important to build your data pipelines in a way and maintain it in a way that you create a impact by showing the responsibility you have towards the company. This slide. Okay, now let's talk about what is the difference between a data engineer and a data scientist, or a data engineer and a BI. So again, I'll go back a bit. So I would say 5 to 6 years ago, there was no job role as a data engineer as such. Most of the job roles back then was more towards big data engineering and big data frameworks. So there was no exactly term like that. And even data scientist is a term which grew big in last, I would say, 5 to 6 years. And business intelligence was the only thing which is actually there. So what has happened in last 6 years is that all these fields have got a specialization of their own. And how I'll differentiate these fields is that, for example, a data engineer provides data to the data scientist, and it basically works with him to understand what kind of data would they need, or what kind of incomplete data do they have, or do they need to pull out more data from other sources or include more fields and things like that. And we work with the data scientist to help him understand what kind of features they can use for the models and stuff like that. So he's the one who's going to be doing the cleaning part. He's the one who's going to be doing the transformation part and finding the sources part. Data scientists will be more, I would say, focused towards understanding, like what kind of models can be built, what kind of regression, supervised, unsupervised learning, what kind of reports and analysis can be done. So that's the role of a data scientist, where his job is more towards the statistical aspect of it than the engineering aspect of it. Coming to the BI role, the business intelligence role, again, is more towards analyzing your data now. So a data engineer also analyzes data. So a data engineer also works heavily on SQL. But a business intelligence engineer's whole job or responsibility is basically to work with more upper management and understanding sales report, understanding marketing report, and stuff like that. So their skill set as a person is more towards analyzing and creating business context of it. And yes, data engineer role has a subset of it, which helps him to basically understand how to create better products, which can help business intelligence engineers to bring more value to the company. So that's how I would differentiate a data engineer versus a BI engineer. Next. Why did I choose data engineering? So actually, I didn't choose data engineering. At least when I graduated, that was not the vision. So before going deep into this, I'll share a journey with you. And this is something why I actually started getting more deeper into data engineering. When I graduated, almost in 2011, I had these jobs. I had this job at TCS offer and a few more IT companies offers, and they have this wait time where you have to wait for a year before you can join. So I just wanted to use my time then to do something in that one year period. So I was applying for jobs, and what was happening is that I got one job which paid me 7,000 rupees as my starting salary right after graduation. This is back in 2011. And the guy told me that he'll pay me 2,000 more if I'll show him that I passed with my certificate. So that's the value I had as an engineer when I just graduated. And that really made me sad then. And I really made me think. I took the offer and I quit the job in 2 weeks too. It was a very horrible experience. But it made me understand that that's what was valued in the market. And this is a very good saying that your value is not determined by what you think about yourself. It's more determined by what people are ready to pay for you. And that thing stuck with me. And then what happened eventually was I'll basically share my journey. So again, I have shared this slide with you guys in my previous talk, but I'm going to twist a bit of what I'm going to talk about here. So I'm not from a very big college. I'm not really great at studies. I talk about all these companies, Facebook and Google, but back in the day, I was not. I went to Viva College. I didn't get good grades. I was having less than 70% in my 10th. I couldn't even get a computer science seat with my CET scores. I was that bad. And I joined as an instrumentation engineer at VSET in Vasai. And I really wanted to do computer science, but no one was offering me a seat. And then by the time I was graduating, first I thought that I'll just become an instrumentation engineer, and that's what I'll do with my career. And I'll probably go to Dubai or Middle East, work for an oil company, make a lot of money. But I realized by end of my 4 years in engineering, that's not something I'm interested in. And I was more interested towards embedded systems. And I was pretty good at it. I was the university topper for that subject. I was pretty good at it. I was very passionate about it. But then there was no job openings for embedded systems in Mumbai. And all the jobs I got were not related to embedded systems. So what I did was I went to CDAC. CDAC is a DRDO research organization's computing facility. And they do 6 months training courses after engineering on specialized app development or embedded systems like that. And I highly recommend people checking it out. A transformational journey. It's a very aggressive program. In 6 months, they complete almost a master's level course. So you really get good at coding and you lose your fears. So that's something I needed. And I did that. I eventually landed a job in embedded systems, Rockwell Collins. It was supposed to be my dream job. I made it. Very few people get that job in India. And it's an aerospace job. I basically was working on cockpits, the auto takeoff, auto landing, and stuff like that. So it was really cool. I was very happy when I joined it. But in 2 years later, I understood that I was not enjoying that job role. And one of the reasons was, which was bugging me, is that I was working very hard. My skill was very important, but I was not having any market value there. In those 2 years when I was working at Rockwell, I got only 2 calls for jobs. One was from Honeywell, and they were not giving me much higher pay. It was pretty much the same pay. And I was pretty angry with that because of that, on embedded systems as a field in general. And so I just decided not to waste more time in India. I thought in US maybe I should do it. I came to US. I went to University of Arizona for my master's, and there I was thinking of continuing with my embedded systems as specialization. But again, that didn't happen. All the good professors for embedded systems left the college that year, and the funding died for research. And I learned this when I was in Rockwell. I learned this. I heard of this term Hadoop, and I had learned that course. So eventually I got a research assistantship in my university on Hadoop, and eventually I got a scholarship from that. And this is the first time I could see a skill generating money for me, and especially in data. And eventually I cracked the hackathon. I made a cool product on a hackathon on sentiment analysis. I landed a job in Xerox, and by that time I was pretty solid that this is the field I wanted to grow because I could really see it creating an impact in my life during that time, especially the monetary aspect of it. And then from there I went to KPMG. It took me a lot of struggle to get to KPMG, and my first job role there was a big data software engineer. Again, that time there was no term like a data engineer, and it again took me 108 companies to finally land a big data role. I had other offers, but I was pretty damn adamant of getting into a data engineering field or data engineering role. And from there, Adobe happened. And when that happened, like my life pretty much changed. I was again like playing with the big boys, solving the most complex problems in the field of data, working with one of the best research scientists in the world. So, and this basically exposed me of the kind of value I can create, and which I just shared with you guys. So this was my journey from starting as an instrumentation engineering to landing at Adobe as a data engineer. And again, the issue with my journey is that I am not the typical data engineer which you will see everywhere. So what I'm going to do is, before I start with my session on, or the Q&A, or start my session or Q&A, I'm going to quickly add in a guest. And this guest of mine is a friend. He's one of my best friends. So I'll invite him to do a podcast-like session. And I'll just give you a quick background about him. So Abhishek he's an engineer from VJTI in IT, from IT department. Back he graduated around 2008, and right now he works as a vice president for Mitsubishi Bank in the data analytics department. So I'm just going to do a quick Q&A podcast-ish like session with him, so that can give you a better understanding and approach, of how you basically get into this field, or what are the aspects you need to do. So let me start the conversation then. Hey Abhishek, can you hear me?
Yeah, can you hear me?
Yeah, perfect. So I was going to say welcome to my show, but this is not really a show. But I hope one day. Again, really happy that I would say you are one of the ideal people. You were one of the CD toppers. You got into VGTI. You were one of the big names back in the day. The ideal journey, you can say, from university. What I would like to do, can you help us, or just talk about your career, how it's been like? How did you, after getting into how did you, get your and where you are right now?
Yeah, before I start, Navin, could you just give me an idea of the audience right now in this seminar? Are they all currently finishing their bachelor's degree?
Yes, most of them are in the 3rd year or the 5 years of the engineering.
Okay. The reason I ask is when I speak, I can give some more context on what kind of anxieties and fears they may have, and and maybe my experience could help them a bit. So yeah, thanks a lot for the introduction. And I did my bachelor's from VJTI in information technology. So I started in 2005 and graduated in 2009. And as some of you may know, 2008, there was a big global recession. And it also impacted India because, as you know, that a lot of our jobs are, servicing, offshore servicing. So I had a campus placement at Tech Mahindra. And I think, Navin, you mentioned earlier, but I had a similar experience where I had an offer, but they didn't call us. I don't even know until when. So I was at home after I had a job, and it was pretty frustrating because a lot of my colleagues had decided to pursue masters, and they were already in the US.
Okay.
So they were posting photos, from all these big cities in America, while I was just sitting at home with my Tech Mahindra job and no career prospects. But I think what I did was I took a short-term gig for like a couple of months. It wasn't related to IT; it was market research, just so that I utilized my time. And until then, I kept applying to other technology jobs, and eventually I landed a role at Citius Tech. Back then, it was a healthcare startup. I think right now they're doing pretty well. So as a software engineer, and so I ended up working there for about a year. But then, as I started working in that role, I mean, I just realized that maybe it's an opportune time for me also to pursue further studies.
Okay.
And maybe this might be something which might help you when you make your decision after you graduate. In my experience, uh, a couple of years or a year of work experience is good enough before you could, consider either an MBA or a master's if you do plan to, study further. Um, the reason I say the earlier the better is because I'm noticing this right now after having graduated from NYU with a master's degree in 2012. And now, when I want to pick up my books and start studying, it's not easy because once you're used to the life of earning a paycheck and you get pretty, let's just say, you get pretty relaxed and you're not in the mood to now pick up a book and start studying again. So maybe the earlier you can get into studying, pursuing a degree, maybe that's a better option. That's just in my personal experience. It may not apply to everyone.
So quick thing. So again, you mentioned you graduated during a recession, right? So this is something the current students are facing right now, right? There's a recession happening, whether the world leaders acknowledge it, right? So what kind of fears do you think, or what are the problems fears a student might have, or what would you advise your younger version graduating right now during this time, because this is a really for a lot of students. Like they are going to be graduating, they do not have a job, they're applying for jobs. So what kind of or a good message you can give?
Yeah, I mean, and I don't want to sound as if I am the enlightened one and I have the answers to everything, uh, but I'll just say what worked for me, and I can relate to, maybe you can relate to some of my anxieties or apprehensions back then. Uh, I think the most frustrating thing for any individual, maybe even a sportsman, if you play sports, is you're part of a team but you're not picked and you're on the bench. Uh, you just start doubting yourself whether if you're good enough. So I think as difficult as it sounds, you should never stop believing in yourself. I think that's like the key to success in any avenue. And this is what happened to me. That okay, I'm not going to deny, but after I graduated from VJTI, I thought, okay, now it's going to be a piece of cake. Everyone's going to just offer me a job, because maybe back then VJTI was still like one of the premier institutions in Bombay. But that wasn't the case, and there weren't many jobs. So it was uncharted territory, because now I had to go on to all those job sites. I think Naukri.com was one I was using back then, and uh, I remember just applying to maybe 50 to 100 jobs. I would say every couple of days, and obviously a lot of them may not directly apply to me, uh, or I didn't get any calls. But I think the biggest piece of advice I can give you is, unless you try, unless you shoot, you'll never score. So unless you apply, there is absolutely no chance it's you'll get a call. So even if as you're applying, you might be telling to yourself mentally that, "Arey yaar, I'm not good enough. मेरे को तो ये लोग कभी बुलाएगा नहीं." But there is really no harm in applying, and you really never know who's going to call you, why they like you. You may not like yourself, but someone will like you because you have something to offer. So I think the biggest thing I'll say is you have to keep trying. And the second thing, just quickly, I'll add is uh, I would say don't ever get complacent. And this is something even I am experiencing right now, having worked for about 7 years here in America, that it's easy to get complacent. But unless you are constantly learning something new, and staying relevant in the market, things will just move on. And as you can see, technology keeps changing every year. So unless you keep learning, no one's going to, no one's going to come up to you and be like, "Hey, have you learned this or have you learned that?" It's all on you. So, so I think the two biggest pieces of advice I can give is, if you do have a period where you don't have a job, then definitely keep applying, forget what anyone says. And the second is continue learning something new.
Cool. One last thing I would ask you is, like, how do you think what would be a good? And this is something a lot of people ask me. How do you choose a career? How do you choose a certain stream, or how you chose your certain stream? Like,
Do you want the honest answer, or do you want the answer with every?
anything you feel like would be helpful for these guys?
Okay, so I think like most Indians, the reason I chose my career is because I really only had two choices, either becoming an engineer or a doctor. And this is true. But I think after I finished like my +2 in science, the only option was to either do engineering. So my real thinking was, how do I choose a degree where I don't have to work too hard, but I also get good returns out of it. So that's why I ended up choosing IT. And I'm honest enough to admit that maybe I'm not as good of a programmer as Naman, but I think this is where I can sort of advise you on how to pick your career. I think you should be honest to yourself what your strengths are. Like, I feel there is really no point if you don't have any interest or passion in, say, programming, for example. You might get that job at Amazon or wherever, at Facebook, but if you're not happy, then every day is going to be miserable. So rather assess what your key sort of strengths are, and I think based on that, I think that was my way of sort of selecting my career, is doing that self introspection, seeing what my strengths are, and then trying to see if I can sort of mesh that with the jobs which are in demand. So just to give you a quick background of me, after I finished my degree at NYU, I was a consultant at Ernst & Young for a couple of years, and then I transitioned to Pricewaterhouse in technology consulting. And as as I was going through the job, I realized that maybe that is sort of a good niche for me, because not only it has some component of technology which I like, but also it has the ability to problem solving and countering challenges and trying to design a solution for the clients. And that is something which I'm more interested in.
Okay, no, that was great. I think we're running out of time now, but I basically answered pretty much all the questions I had.
Okay, great. Yeah.
Thank you so much, Abhishek. This was really helpful, and I hope all the students can take this advice and do well in their careers. Thank you so much.
Sure, man. Yeah. Thank you.
That's pretty much I can start the Q&A session now.
So if anybody has any doubts or queries, kindly post them in the chat box.
No questions. Either everyone understood everything or no one understood anything. Is Java worth learning? Yes, and so there's the thing, right? So Java is just a programming language. What you do with Java is more important, right? So what are you trying to become with Java? What I advise all the computer science students is to learn one language really well, and this is what most of the people get wrong. They just try to focus on technologies and learn multiple things, and that's something I would really suggest not to do. Whatever language you focused or like you think you're comfortable with, you focus in that language and learn that end to end. Okay, because data engineering can be done in Java, right? Backend can be done in Java. So Java will give you the prospects of doing well in a certain stream, so expertising in one language is very important. But again, if you know you're going to do a certain stream, it's always advantageous to pick a programming language which is more popular in that stream. So if you want to become a data engineer, and that's your goal, if you want to become a data scientist, that's your goal, I would highly recommend learning Python then, because it's difficult to do data science with Java. You can still do it. It's just a bit difficult because there are less packages available. I hope that answers. Again, right? So in Java, it's basically you can learn frameworks in Java, right? You learn Spring Boot framework in Java. That's basically your REST services, right? Then you have a lot of other frameworks you can learn in Java, which will make you a web developer. But again, your goal there is becoming a web developer. If you keep your skill sets more focused towards the programming language, you're getting better at the programming language, but not in the industry of that. So your goal should be to become a good backend engineer. Okay, and that can be just not learning Java, but also other concepts of data engineering like real-time data pipelines or Kafka or something like that. Right? So your focus should be that. Again, when I mean Java, you should know Java end to end. There's no particular aspect कि ये function है लिखेंगे बाकी नहीं लिखेंगे. That's not how it works. Like you need to learn how to use Java to build things. Okay, and then frameworks, it's your choice of what kind of field you want to grow in as an engineer. Honestly, so the question is, my bad. The question is, how do we really come to know where our interest lies? So, so I'll tell you my experience. I don't know how other people do it. I just learned by failing. Okay, and it's just not in work itself, in other aspects of my life too. I just learned that there are a few things you will do and you will enjoy while you're doing that, and that only happens with experience. You can think that you might like something and eventually start doing that thing. For example, for myself, when I started to do embed systems, I thought I would like that, but eventually I figured that I didn't really like it, and the money aspect was a very big factor for me. Okay, I was not getting the money returns for the amount of efforts I was putting in. So that really changed my approach towards data engineering then, because when I started doing more data engineering, I could see the relative outcomes. So money was a big factor for me, but also learning is something I really like. I really like to learn new technologies and build new things, which is not something that happens in embedded systems a lot. But it constantly happens in data engineering, and that's the challenge I like to face. So only by trying things you'll understand that you like or not like, and the more things you try and the more things you fail, that's what you will find it much more easier or earlier that where your interest lies. Would data engineering be worth learning? Oh, sorry. Wait, yeah, okay. Would data engineering be worth learning or pursuing in the future? As you told, to make basic models and data modeling as well, how can we make it? So, well, data engineering is definitely worth it because usually anywhere you're dealing with data from the time you wake up, right? And now, especially with Geo, like making everything like online, and with the whole internet boom in India, everything is getting online. And I was just talking to my mom, and mom like orders more stuff from on Amazon in India than I actually do in US. So what's happening is all the things around you are turning towards data, and so this is basically is creating more data day by day. I mean, there is no less data problem. Right now, we are reaching a point that we don't have enough space to store data. Okay, so everyone is trying to get good data engineers in the field, and this field is going to evolve with more complexity. Okay, for example, 5 years or 6 years ago, 1 terabyte was a lot of data. But recently, when I was interviewing with Netflix, right, and they basically said that the small data sets they have is 50 petabytes and petabytes, right? That's insane, and that's a streaming website which you watch, and you won't even think about that. So data engineering is there for the long term, and there is no worry about this. And you can definitely make it. But again, cracking it is difficult. You need to learn the things the right way, right, apply for the right opportunities. You might not get a data engineering job right out of college, but you need to make your way through, maybe learning backend or working with data engineers or just helping BI analysts and eventually getting into that field. So next question, approach to becoming data engineer and what basic steps we should initiate. Or is there any particular path to follow or reach at the position of a data engineering? So the approach would be really master the skills I just talked about, right? Really master one coding language, ideally Python, really master your SQL skills, really master your data modeling skills, okay? And once you have these things in place, try to go out there and learn a big data framework, or try to do, learn a cloud. Every cloud has its own data engineering tool sets now. So Google has its own tool sets, Microsoft has its own tool sets, AWS has its own tool sets and certifications. To try to see that, try to learn that. And again, it might be too much initially, but that's but as an more expected to know the basic fundamentals. So try to keep your focus on that and try to make projects on those things. Take a small data set, make a quick data visualizations on it on your local area or something like that, and put that on your resume, because that shows your intention to learn that thing, right? And learn how to make proof of concepts on it, or learn big data frameworks. That also shows your interest towards that field. That can actually get you a start, and that's how I got a start. Okay, I'll go to the next. How much is a data engineer paid annually? I'll tell you about the gold standards, and I still don't know exactly how much they get paid in India. A good data engineer in Netflix, and I'll be talking US salary, so it might be a bit too much, and that's not realistic. Honestly, very few people get that. Like maybe 0.001% of engineers make that, but like a Netflix engineer, right out of college, will make 200K. That's almost like 1.5 crores a year. That's a Netflix engineer. But getting into Netflix is very extremely difficult. And like those are the best engineers. You just go up from there. Okay, a senior engineer can make somewhere from around 300,000 to $500,000. That's around like 3.5 crores. And that's Netflix. That's the Google standard. Like basically means that you're the god of that field. Okay, but and like Facebook, Apple, Amazon, Google also pay like similar to what Netflix pays, a bit less. But if you come to India, like again, there are like a lot of startups trying to build the startup. You can get a good I would say a good package. If you're an experienced data engineer, at least you build something on a particular cloud and you have a cloud expertise of 2 years, you can expect 20 to 30 lakhs in India. I had a friend who just recently moved back from US to India because she can get her H1B picked up here. She now works for 12 and got a package of around 20 to 25 lakhs. And that's also not having a ton of experience. You're just having an experience of a year and a half in data engineering or data analysis. So that's how I would benchmark it. A very good new grad would make. Again, new grad is very complicated in India. The tiers are different. So what I would say is 2 years good experienced data engineers build some good stuff on expertise on a cloud can make 20 plus lakhs. Yeah. Okay. In web designing, if you know HTML pretty well, then is it mandatory to know WordPress or any other main websites? So if you're becoming a web designer, again, your focus is again should be on the frameworks which are now being used. I think React is the pretty, I would say, used JavaScript framework right now today's world in web designing. And I'm not an expert, so I don't take my word for it. But again, WordPress won't get you far. Like for example, Facebook, Google, these people don't work on WordPress. So you need to expertise on things which the best in the industry expertise on. Like Facebook built React, right? So that's the web designing tool they use to build their web frameworks. So if you want to become a good engineer, first expertise in JavaScript and then learn React in and out. And React engineers are very much in demand. Okay, but everything in React goes to the fundamentals of JavaScript. You have to be a very good JavaScript engineer for that. Software development engineer versus a data engineer. So what does software development engineer can be a generic role. Okay, it can be doing anything from backend to doing any in-house code. Okay, so it doesn't have to be developing data pipelines. It can have it, but it doesn't necessarily have to be. You can be just working on some backend JavaScript or Python script or something like that, or some internal tools which the company has itself. So software development engineer, again, it's a very vague term. But if you get an SDE in Amazon or Google, you probably will be working on some, they will probably ask you what kind of stuff you want to work on, or you'll probably work on something in terms of backend, because they usually have a very, I would say, descriptive roles for their job titles. Our current situations troublesome with job perspectives are okay for upcoming engineers. It will be tough. I will be honest. Like getting a job coming ahead will be tough because a lot of people are getting laid off, right? So when hiring happens again, the first focus will be to hire, there'll be a lot of engineers and few jobs. So the jobs you're going to be competing, or experienced engineer will be competing with you. So yes, it will be tough. And that's why I got an Abhishek just to share his experience, right? Because he went through this phase. He was sitting at home, and that's a phase you might have to go through, or you might not even have to. I don't know, because depending on the vaccine and how they comes and how the economy changes again in a year, right? But there will be still some significant impact, right? And yeah, that is a possibility that there will be issues. So you have to be up to your speed. Make sure that you're learning stuff. Have your resume much better than your competitors. Also, you told to make basic code, that is data modeling well. How can we make it? So, you should probably read more books on data modeling. There's a really good book called as The Star Schema or Data Warehousing Toolkit by Kimball. Those are like the Bibles for data modeling. So I would recommend reading that, learning that, or just go online and solve data modeling questions on LeetCode or HackerRank and stuff like that. So that can also really help you to get better at this. That was, I guess, the last question I had on the charts.
All right. So a final call for any queries. If any queries, then please post it on the chat box. Else we will wind up the event. All right. So as there's nothing to come up yet, I guess this is the end of the session. Well then, from the structure of the job to the topics in it, the core concepts, it was totally worth our time. Also, the core highlight was the pod that we just had with Mr. Abhishek, whose story was really something it had the punch. So thank you, Mr. Naveen, and thank you, Mr. Abhishek. This was seriously the most casual and informal type of webinar that we've ever had, not gonna lie. Also, thank you for the patience that you have had in dealing with the questions. Overall, We really loved the webinar. So once again, thank you.
Oh, thank you for having me here. It's really I feel great like talking about my experience, and I'm really glad you guys like the podcast ish style.
Naveen, thank you so much for taking time from your busy schedule and accepting the invite and having a great session. And definitely, the podcast was also great. Something that I think every undergrad would face when the story what Abhishek was going through. I think many of them are going through also, or maybe in future they would have such a situation. So just a word of advice that don't get something good that will definitely come all your way. Just wait patiently and definitely you'll get what you deserve. So thank you so much, Naveen, for the session, and I hope our participants enjoyed it. Great.
Thank you.
Thank you, Vivian sir. So I guess this is the end. So uh, Naveen sir, the entire SJCEM would wish you all the very best for your future. And students, please take a note that there is a feedback link which has been posted in the chat box. So do not forget to post that to fill the feedback link. Thank you so much.
Thank you. Yeah.
I'll request all the participants to turn on their videos along with Naveen sir so that we can just have a quick group pic.
Kindly turn on your video cams, and there's also an announcement regarding the certificates. The registered participants shall be receiving the e-certificates as soon as possible. Thank you.
Yeah, requesting all to just turn on their videos for a quick group pic. Naveen, are you there online? Okay, I'll just request him to join. I think he just. Yeah, just wait for a moment. Others can just keep their video on till then. Requesting all the members to please turn on their video just for a group pic. Yeah. I'll just have a group screenshot. All right. Great. Thank you so much. Thank you, Naveen, once again.
No worries. Thank you.
Yeah, great.
Thank you all. The participants can now exit.